Hi, welcome to MS 100 lessons, and in today's lesson I will be doing limiting reagents. Looking at the outcomes for this lesson, I will first state out the definition of the limiting reagent, and learning outcome number 2, I will show you how to determine the limiting reagent from a calculation. Right, so let's say we have a scenario whereby we have a reactant, right? Let's say we have reactant A, and we also have reactant B, and we take these two reactants and then we mix them. So let's say we have a container, and assuming that reactant A is a liquid and reactant B is also a liquid, right? So let's say we pour reactant A in this container, right? So let's say this is reactant A, and then we also pour reactant B in this container also. And then let's have an assumption of the product. So let's say the product, if you mix the two, you get something which is yellow. So yellow is our product, which is also a liquid, right? So let's say you pour A and B in the same container, and then you allow these two to react, right? And then after some time, you find that there is a yellow product in that container. There is a yellow product, so it means A and B reacted to produce this yellow product. But you also find that there is also some of the orange liquid that did not react, right? So some of the orange liquid reacted, but after some time, when the reaction is complete, you find that there is still some of the orange reactant that has not reacted, right? But question is, where is the blue liquid? So we can say that the blue liquid has reacted with some of A liquid to form this yellow product, right? To form this yellow product. And we can also conclude that some of the orange did not participate in the reaction, right? Did not react. So this means that the reactant A was in excess. We had excess amount of reactant A. We had more than we needed for us to form product B, or for us to form the product, right? So now, what can we conclude about reactant B? So reactant B was used up, right? Reactant B was completely used up, because after some time, or after the reaction was complete, we did not have any liquid B remaining in the container, right? We only had the product, which is yellow, which is a combination of A and B, right? But we also had some orange liquid that did not react. So that amount that did not react, that is the excess amount of reactant A, right? But why don't we have the blue liquid in the product? That is because reactant B was completely used up in the reaction, right? So we can simply say reactant B was the limiting reagent because it was completely used up in the chemical reaction. So what will happen if we add more of reactant A in the reaction? Let's say we add more reactant A in the reaction. We would still get the same amount of product, of the yellow product, but now we would have more orange liquid left, right? Because reactant A was already in excess, right? If you add more excess, you make no difference to the amount of product that you are going to get, right? But what if we add more amounts of liquid B to the initial reaction? Then that means the amount of product that we will get at the end would increase, right? So the amount of product that we get is limited by the limiting reagent, which is the amount of reactant B, right? So in a chemical reaction, say you have two reactants, which is A and B, right? Liquid A and liquid B, and you want to produce liquid C, and you find that liquid A is in excess, right? Then it means liquid B is the limiting reagent. So the amount of product that we would get is limited by the amount of B, such as in this case, right? So what is the limiting reagent? Let's go back to the definition. What is the limiting reagent? So the limiting reagent is the reactant that is completely used up in a chemical reaction. Right? So the key term there is that the reactant is completely used up. So you no longer have that reactant after the reaction is completed. So that is the limiting reagent, the reactant that is completely used up in a chemical reaction, right? So how do we determine the limiting reagent? Through calculation. So let's have an example. Let's say we have magnesium, which is solid, right? And we have 12 grams of this magnesium. This magnesium will react with oxygen, gas, and we have, let's say, 7 grams of that oxygen gas. So this would react to produce magnesium oxide, right? And if we balance the reaction, we'd have 2 MgO and 2 magnesium, right? We have 2 magnesium on the left hand side, we have 2 magnesium. On the right hand side, we have 2 oxygen and we have 2 oxygen. So the reaction is balanced, right? So we are going to produce product MgO, which is magnesium oxide. But now the amount of product that we produce is limited by the limiting reagent, right? So we have to check which one is the limiting reagent between magnesium and oxygen. And that is what we're going to use to calculate the amount of magnesium oxide that would be formed, right? So the steps that one has to follow in order to determine the limiting reagent. Step number 1, you make sure that your reactants are in number of moles. Convert your reactants into moles. Step number 2, use a ratio to determine how much product is formed. It's formed by each reactant. Right, and number 3, the reactant that produces less of the product, that is the limiting reagent. So the reactant that produces less of the product is the limiting reagent. Alright, so these steps might not make sense at the moment, but it will make sense as we perform the calculation, right? So we said we had magnesium reacting with oxygen gas to form magnesium oxide, right? And we had 12 grams of magnesium and 7 grams of oxygen. So now we have to determine which one is the limiting reagent between magnesium and oxygen gas, right? We said step number 1, you convert your reactants into number of moles, right? So let's go to step 1. We have magnesium. Let's convert whatever we have for magnesium into number of moles, and then we're going to convert whatever we have for oxygen into number of moles, right? For magnesium, we have 12 grams of magnesium. So how do we convert mass into number of moles? We use the formula number of moles is equal to mass over molar mass, right? The number of moles is equal to the mass is 12, and the molar mass for magnesium from the periodic table is 24, right? So the number of moles for magnesium is equal to 12 divided by 24, and that will give us 0.5. So we have 0.5 moles of magnesium, right? So now let's go and convert whatever we have for oxygen into number of moles. So for oxygen, we had 7 grams of oxygen, right? And how do we convert mass into number of moles? We use the formula number of moles is equal to mass over molar mass, right? And number of moles is equal to the mass of oxygen gas is 7, and the molar mass is 2 times 16, right? Because we have 2 oxygen, and that would give us 0.219 moles, right? So we have completed step number 1. We have converted whatever we had into moles, and according to our calculation we have 0.5 moles of magnesium and we have 0.219 moles of oxygen gas, right? So step number 2, you use your ratio to determine the product formed, right? You use a ratio to determine the product formed by each reactant, right? So let's start by using magnesium. So we want to use, that is step number 2, we want to use magnesium in order for us to check how much magnesium can we get, or how much magnesium oxide can we get from that magnesium, right? So the ratio that we have is taken from the balancing numbers, right? So in this case we have 2 for magnesium and we have 2 for magnesium oxide, right? So that would be 2:2, which is the same as 1:1, right? So now how much moles of magnesium do we have? We have 0.5, and we want to check how much can we produce with that 0.5, right? If you have 2 moles of magnesium, you can produce 2 moles of magnesium oxide, right? So this ratio is the same as 1:1. So if you have 1 mole of magnesium, you can produce 1 mole of magnesium oxide, right? So at the moment, let's just work with the 2 that we just took directly from the equation. So now we can just cross multiply to check what is the value of x, or to check how much can we produce of the magnesium oxide, right? So that would be 2 times x, that would be 2 times 0.5, right? And that would be 2x equal to 1 divided by 2 divided by 2, and then x is equal to 0.5 moles. So it means the number of moles for magnesium oxide that we can produce is 0.5 if we use magnesium, right? So now let's also check how much magnesium oxide can we produce using oxygen, right? How much magnesium oxide can we produce using oxygen gas, right? And the ratio from the equation, we have 1 for oxygen and we have 2 for magnesium oxide. So the ratio would be 1:2, right? So how much do we have available for the oxygen? We have 0.219, 0.219, and we want to calculate the amount of magnesium oxide that we would produce using oxygen, right? So here we cross multiply, and that would be 1 times x equals to 2 times 0.219, and that would be x, and that would be 2 times 0.219, that is 0.438 moles. So the number of moles for magnesium oxide that we can produce with oxygen, we can produce 0.438 moles, right? So that is step number 2. We check how much of the product we can produce using each reactant. So with magnesium, we can produce 0.5 magnesium oxide. But with oxygen, we can produce 0.438 moles of magnesium oxide. So for step number 3, we said the reactant that produces less, of the product is the limiting reagent. So now let's decide which one produces less between magnesium and oxygen gas. So if magnesium produces 0.5 moles, right? but oxygen produces only 0.438 moles. So it means oxygen produces less of the product, right? So that is the limiting reagent. So that is how we determine the limiting reagent. So number 3, can simply say oxygen gas is the limiting reagent. And why? This is because it produces less product, right? So now it means if we want to calculate the amount of product formed, we have to use the limiting reagent, and in this case the limiting reagent is oxygen gas. Therefore, we can also conclude that magnesium is in excess. So this is the excess product, the excess reactant, but oxygen gas is the limiting reagent. So it means oxygen will be completely used up. In this chemical reaction. So that brings us to the end of the second learning outcome, which is how to determine the limiting reagent. You have to follow some simple steps. You have to make sure that everything is in number of moles. You have to use the ratio in order for you to determine how much of the product can you produce by each reactant, and then the one that produces less, that is your limiting reagent. Thank you.